Good morning, all of you. I, Dr. Badri Mohapatra, Assistant Professor, Instrumentation Engineering Department of AISMS IOIT. Today, we will be discussing on control system. So, in control system, we have to find the transfer function of mechanical system. So, particularly for finding the transfer function of any mechanical system, so we have to know the basic mechanical vibration system. So next, what are the spring damper model system, and we have to discuss one example of how to find the transfer function of any mechanical system. So basically, that introduction of mechanical vibration system, particularly in mechanical transmission system, we are having three different parameters. Like one is mass, then another is spring, and another is dampers. Okay, so mass having represented as m, and it will be measured in terms of kg. Spring having stiffness, spring stiffness, which will be represented as k, and damper, that is the coefficient. It will be represented by SB. The associated variables are displacement x of t, then force f of t, and conventional. The basic elements are represented symbolically. We have to be represent mass as m, then spring, and then this is the damper system. So mass which will be represented as m, then spring represented as k, and damper representation as b. So if there will be some displacement, then x1 and x2, which we have to be defined, so that will be modified accordingly. And the next thing is that the mass spring damper system, this is some relationship between force and displacement, that how much force which will be applied to mass. So how that relationship between mass and force. So F equal to, normally we know m into A. So that is mass into acceleration. So m into d square x by dt square. So that is also can be represented as mx double dot. So spring, so similarly force is related with spring. So F equal to K, that is the stiffness constant, or with respect to x2 minus x1. So depending on that, the force applied to that spring, this is a relationship which will be generated. Similarly for the damper, it will be generated by F equal to B dx2 by d2 minus dx1 by dt. So if we are taking one example of mass damper system, suppose in the right hand side, this is the block diagram, or you can say this is the diagram which will be given in question. So particularly here mass value will be given 1, K value will be 25, and B value will be 6, that is damper coefficient value will be 6. So when this mass, okay, and if there will be some force which will be applied to this system, then we need to find that equation, and after that equation we find the Laplace transformation, and after that we will be find the exact system function, or you can say transfer function of that system. So here you can look at here that when there will be relation with mass, so m x double t is equal to f of t minus f1t minus f2t. So you will be put mass value equal to 1, then f of t value equal to 4 sin omega t, then f1t equal to this 25 as per that questions. All the values will be given. So after putting all this information, then we need to be find the Laplace transform of that equation. So after finding that Laplace transformation, we will be find the exact transfer function of that system. Thank you.